All right, hi everyone. We are looking at our next topic in our relationships with triangles. So today we're going to look at a theorem that's called the triangle inequality theorem. So let's take a look at what that means for us today. All right, so the triangle inequality theorem is a theorem that basically describes how you can create a triangle, because not every group of three numbers is long enough to actually make that triangle. So in order to make a triangle, the theorem says that the sum of the two shorter sides must be greater than the length of the third side. So we have to find the two shorter sides, or the two smaller numbers, add them together, and it must be bigger than the leftover third side. So we've got an example here, three triangles. They all look like they could be triangles, but again, it's based off of the numbers. So we need to find first off the two smaller sides. So for our first triangle, 8 and 13, we're going to add them together. So 8 plus 13, which gives us 21. We take that 21 and compare it to the last side of the triangle. In this case, they are equal, so no triangle. Again, the sum has to be greater. Let's try the next one. Same 8, same 13. Add those together. 21. Compare that 21 to the third side. It is bigger, so there is a triangle. Let's check the last one. Same 8, same 13. So that 21 to the third side, it is smaller, so no triangle. So again, the only way that we got a triangle is when the sum was bigger. When we added them up, it was bigger than the leftover third side of the triangle. If they were equal, not a triangle. If it was smaller, not a triangle. So using that same idea, let's check out the examples we have down below. So we've got three numbers here, 1, 4, and 6. Add up the two smaller numbers. So that gives us a 5. What is 5 to 6? Well, 5 is less than 6, so no triangle. Let's do the next one. 17, 17, 33. Again, add up the two smaller numbers, which is 34. Compare 34 to 33. It is greater, so there is a triangle. We can make a triangle out of that. Let's check C. C is a little different. All three numbers are exactly the same. So if that happens, it does not matter what two you pick, because again, they're always going to be smaller. We add those two nines up, 18, compare it to our leftover 9. 18 is greater than that third side, so another yes. And then we do our last set down here. Add your two smaller numbers, 5 and 5, which is a 10. Compare it to the last side that's there, another 10. They are equal. No triangle. All right. So we've seen what happens when they give us three possible sides. Let's see what happens now if they only give us two sides. So a triangle has a side length of 8 and 12, or 12 and 8. And that's it. They only know two. We want to find the possible range of numbers that could work for the third side. So problem is, we don't know if 12 and 8 are the smaller two, or maybe 12 is the biggest and 8 and something else are the small. So let's say we do two cases here. Let's say they're giving us the two smalls. Well, the rule says I should be able to add them up. My missing side. So add them up. It has to be bigger than the third side. So 8 and 12 has to be greater than the third side. So 20 has to be the biggest. So my side has to be smaller than 20. What if they give you the small, or they give you the large and one of the others? So it's a little different. We can't just add them up this time. This time we can subtract them. Let's say they give you a small or the medium. With the largest. So in this case, we subtract, because let's say if 8 is the small, 8 plus something has to be less, I'm sorry, not less, greater. 8 plus something, the sum of my two smaller, has to be greater than the third side. So it would need to be greater than 12. So in this case, we have a little bit of an algebra problem to solve. So we'll subtract the 8 on both sides. And my missing side has to be bigger than 4. So let's see if we can come up with a formula to help us remember this process. And I call this the third side formula. So we are looking at to find this missing side. So x is missing side. My missing x has to be greater than the minus, so greater than the difference. I'm going to have to move this over. Sorry about that. So my x has to be bigger than the difference, but smaller than the sum. So with those exact same two numbers that we have, our difference will do 12 minus 8 is less than x and less than the sum 12 plus 8. So we get the same 4 are less than x less than 12 plus 8, which is 20. So my entire range are any of the numbers that would fit between 4 and 20, but not equal to 4 and not equal to 20. So 5 could work, 6 could work, anything between those two numbers, but it cannot be equal to those two numbers. So 5, even 4.1 could work. Okay, guys, I hope you enjoyed learning a little bit about what it takes to actually make a triangle, because again, if we cannot make a triangle, then all of those special segments we looked at in the last several class days would not be possible. So I hope you enjoyed learning a little bit about what it takes to actually make a triangle. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.